Alright, let's get after this review. I'm going to go through the odds. I may not do all of them, but I'll do quite a bit of or quite a few of them, and I'll try to do a lot of different methods. Okay, so we've got this equation here, n squared equals 3n, and we want to solve. For n. Alright, so the first thing I would do is I would move that n, 3n to the other side, so that I would have n squared minus 3n equals 0. Okay? And so what you might see here is that you could divide everything by n. Okay, so, and then you would end up with n minus 3 equals 0. But what happens there is you lose a factor. So rather than divide by n, let's factor an n out. And we'll get n times n minus 3 equals 0. And then we've got two things that we can set equal to 0. N equals 0 and n minus 3 equals 0. When we solve for that, we get n equals 3 and n equals 0, which are the two answers that they have right there. Here. Alright, let's go now to number 3. Let's go to blue, a little more pleasing, pacifying color. Alright, I got an m squared plus 12x minus 64 equals 0. Okay, everything's set equal to 0. That means I can start to do either quadratic formula, complete the square, factor if I can. So what I'm going to do is I'm going to try to factor it. If I can factor it, I like that. So, are there factors of negative 64 that add up to 12? And if you're cheating and looking at the answer, maybe you'll know the solutions there. But what I want to do over here is just demonstrate again, if you have forgotten, how you can do that. So you got x squared plus 12x minus 64. No, that's not what I want to do. I want to do negative 64. I need factors of negative 64 that add up to 12. So you do negative 64 divided by x and go to the table. Alright, and they need to add up to 12. And so, boom, right away, you see 16 minus 4 is 12. Okay, so, that's not what I want. So, the two factors we're looking for are 16 and negative 4. So we put those back in, m plus 16 times m minus 4 is equal to 0. And then we get our two answers, m plus 16 equals 0, or m equals negative 16, and m minus 4 equals 0, m equals 4. And I'm going to take a little bit of them, or put a little bit mystery back into this and hide those answers. Alright, let's jump now to number 5 here. Okay, let's try to factor it. You know, are there factors of negative 47 that add up to 8? Alright, well, color me skeptical. I'm not really sure that there are, but we don't have to wonder. We can just run to the calculator and do negative 47 divided by x. And let's go look for some factors. I need it to add up to 8. Okay, so just as I suspected, 47 ain't nothing but a prime number. Okay, so it's not going to factor for us. So there's other methods we can do. We can do the quadratic formula. I like this when it has a leading coefficient of 1 and then it has an even middle term, so I'm going to complete the square with it. Okay, so let's go. So to complete the square, I'm going to first move that 47 to the other side. Alright, and then I need two things to complete this square. I need the middle term divided by 2, and I need the middle term divided by 2 squared. Okay, so I'm going to use that 16 and that 4. Alright, so what goes over here in the empty space? That's the b over 2 squared. And then what goes in here, it's the b over 2. Okay. And that's 63 Okay. So now we take the square root of both sides, and we get n plus 4 is equal to plus or minus the square root of 63. Okay. So 63, that would be 9 times 7, right? Okay, so n plus 4 is equal to plus or minus the square root of 9 times 7. Okay, and we can take out the 9 and leave the 7 behind. So we get n equals negative 4 plus or minus 3, because that's the square root of 9. Okay, we take the square root of it. It's not under the square root sign anymore, but we haven't taken the square root of 7, and so it's still under there. And let's see. That's not what I want. That's what I want. So negative 4 plus 3 square root of 7, negative 4 minus 3 square root of 7. Very good. So in this answer down here in the blue, we have two solutions. One of them is the number negative 4 plus this number 3 square root of 7. But it's an irrational number, so we're just going to leave it like that. We're not going to try to take the square root of 7. That will result in a lot of rounding. All right. Let's do this one now. This looks like fun. So fun, I'll do it in green. Okay, so we want to factor this maybe. I don't know. We're going to do something with it. But what I see right away is that this whole thing can divide by 2 at the very least. Okay, so I can divide all these things by 2, and I get 3v squared plus 6v plus 4 is equal to 0. Okay? I can't factor anything else out, but what I am going to do is see if I can, I don't think I can, but I want to see if I could find, so can I factor this by the bottoms up method? 3 times 4 is 12. Are there factors of 12 that will add up to 6? Unfortunately, no. If there was a 7 in the middle there, I could make that work, but I can't. So I've got a leading coefficient of 3. That's odd. I don't like that. So what I'm going to do is I'm going to use the quadratic formula, which I don't do a whole lot. So that's saying something. So I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, negative 6, plus or minus the square root of, what's b squared? 6 squared is 36, minus 4 times a, which is 3, times c, which is 4, all over 2a. So we got negative 6 plus or minus the square root of 36 minus 48. So that's negative 12 over 6. Alright, so I can see clearly now that I'm going to have an I. And then the square root of 12, well, I can break that up into the square root of 3 and the square root of 4 all over 6 still. Okay, and so I've got negative 6 plus or minus, square root of 4 is 2i times the square root of 3 over 6. Alright, now I can divide all those things by 2. This divided by 2, divided by 2, and I get negative 3 plus or minus I square root of 3 over 3. And that's what v equals when that whole equation equals 0. And check that one. Negative 3 plus or minus I square root of 3 over 3. So we got it. Alright, I'm going to call it quits right there for this video, and we'll pick up on this review with another one.